Okay, in this video we're going to be talking about algebra proofs. Now, a proof is just a set of statements and reasons that lead to a logical conclusion, and an algebra proof is just a specific type of proof. It's a proof where you start with an algebra equation and you solve it. Instead of solving it like the regular way, you solve it in a very formal way using what we call the two-column proof format, and we're going to learn what that is right now. So the two-column proof format, you'll have a given statement and sometimes more than one given statement, and then you have something that you're trying to prove. So in this case, our given statement is this equation, 2x plus 3 equals 15, and we're asked to prove that x is equal to 6. And the way we're going to do that is we're going to write down our statements, which are essentially going to be the steps in our proof, and then for each statement we write down, we're going to provide a reason that says why we have made that statement. Each one of our reasons for an algebra proof is going to be one of our properties of equality. So let's see what this two-column proof would look like. We're given this statement, 2x plus 3 equals 15. So we're going to start with what we're given, 2x plus 3 equals 15. And the reason that we can write down this statement is because it's given. Our next statement here, we're going to ask ourselves, well, what would be the first step we would take in solving this equation and getting down to our x equals line? And I can see that the first step in solving this equation, I want to subtract 3 from both sides of the equation. So if I take this side of the equation and subtract 3, and I take this side of the equation and subtract 3, well, anytime I subtract the same thing from both sides of the equation, I know that is the subtraction property. And so I write down subtraction property for my reasons for this second statement. So my third statement, since I've subtracted 3 from both sides, the next thing I want to do is I want to collect like terms or simplify my equation. So plus 3 and negative 3, that means my 3's are going to go away here. I'm going to have 2x equals 15 minus 3 is 12. And that reason, the reason I'm able to do that is the simplifying property. My next step in solving this equation, I want to divide both sides of my equation by 2. So I would write 2x divided by 2 equals 12 divided by 2. My reason for being able to do this, I know I can always divide both sides of my equation by 2 because that's called the division property. And finally, once again, I want to simplify. My last step is basically to cancel out these two numbers, and then 12 divided by 2 is 6, and I'm left with x equals 6. And my reason for being able to do that is the simplifying property. And I'm finished. I have 5 steps in my proof. I started with my given information, and I took a series of steps, a set of statements, and accompanying reasons that led to my conclusion, what it was that I was trying to prove. Let's take a look at another example. Here we have example number 2, and I'm given another statement here. 2 times 5x minus 3 equals 8 plus 3x, and here I want to prove that x is equal to 2. All right, once again, I'm going to start with my given information. 2 times 5x minus 3 equals 8 plus 3x. My reason, the reason that I'm starting with that statement is because it's given. Now the first thing I want to do here is I want to use my distributive property so I can get rid of my parentheses here. So if I distribute my 2 through here, that's going to give me 10x minus 6 equals 8 plus 3x. And my reason that I know I can do that is the distributive property of equality. And let's see, my next statement here, if I add 6 to both sides of my equation, then I can get rid of the 6 on this side and kind of move it over to this side. So let's see, if I subtract 6, if I add 6, I want to add 6 since I'm subtracting here. So 10x minus 6, add 6 to this side, and also add 6 to this side. Well, anytime I add the same thing to both sides of an equation, I'm using the addition property. So that's going to be my reason for my step number 3. Next thing I want to do is I want to simplify. I want to combine these like terms here. So negative 6 and 6, that means those 6's go away. I'm left with 10x on this side. My 8 and my 6 combine here to give me 14. And I've just used the simplifying property. And let's see, my next step, I would like to get all my x's together, which means I want to subtract both sides of my equation, subtract 3x from both sides of my equation. So let's see, 10x minus 3x, I subtract 3x on this side. 14 plus 3x, and I subtract 3x on this side. Anytime I subtract the same thing from both sides of the equation, I'm using the subtraction property. And let's see, once again, I want to combine all my like terms, which means I'm going to simplify. 10x minus 3x is 7x. Positive 3x and negative 3x, that means my x's go away, so I'm left with 14 over here. And I've just used the simplifying property again. And let's see, now I would like to divide both sides of my equation by 7 so that I can get x by itself. So 7x divided by 7, 14 divided by 7. Anytime I divide both sides of my equation by the same thing, I'm using the division property. And finally, I'm going to once again simplify. I'm going to cancel my 7's here. 14 divided by 7 is going to give me 2. And I've used the simplifying property. And I've proved that x is equal to 2, which is what it was that I set out to prove. All right, now let's take a look at another example. Example number 3. And now this one, I want you to try this one on your own before you take a look at this one. Go ahead and pause the video right here and see if you can write down the statements and the reasons that are going to go along with this proof. And after you've tried that, you can unpause the video again and you can watch how I work through the proof. So go ahead and pause the video here, try that on your own, and then come back. Okay, so my first step, I remember I always start with the given information. So 7x plus 16 equals 3x plus 48. My reason for being able to do that, that's my given statement. And let's see, the first thing I would like to do here is, I think I'm going to want to subtract 16 from both sides of my equation. So subtract 16 from this side, and subtract 16 from this side. That's the subtraction property of equality. Now that I've subtracted 16 from both sides, I would like to collect my like terms here. So my 16's go away on this side, and my 48 and my 16 get combined into positive 32. That's the simplifying property. And let's see, my next step, I would like to get all my x's together, so I'm going to want to subtract 3x from both sides of my equation. So let's see, subtract 3x here, and subtract 3x from this side. And I'm using my subtraction property again. And again, I would like to collect my like terms. 7x minus 3x is 4x. And my 3x's go away here, so I have 4x equals 32. And again, that's my simplifying property. And let's see, I would like to now divide both sides by 4 so I can get x by itself. So if I divide both sides by 4, now my equation looks like this. And since I've divided both sides by 4, I just use the division property. And finally, I have one last step, which is just another simplification. My 4's are going to cancel. 32 divided by 4 is 8. And that is, again, using the simplifying property. and I've used these series of steps and reasons to prove that x equals 8 starting from my given statement. Okay, one last example. And again, I'd like you to pause the video here and see if you can work out the steps, the statements, and the reasons that you would use to solve this equation. So again, try pausing the video here, see if you can work through it on your own, and then come back and you can see how I work through it. Okay, so we start with our given information, which is 2x minus 13 over 3 equals negative 9. And now the first thing we want to do here, that is the second step in our proof, is we want to multiply both sides of our equation by 3, and that's going to get rid of the 3 in the denominator here. So if I multiply both sides of my equation by 3, well, anytime I multiply both sides of my equation by the same number, I'm using the multiplication property. Now, multiplying both sides of my equation by 3, that's going to allow me to simplify this side by canceling my 3's here. That's going to give me 2x minus 13. Negative 9 times 3 is negative 27. And that's just simplifying. So that's my simplifying property. Now I have a fairly simple equation that I should be able to solve very similarly to the ones that I just did in the previous proofs. So let's see, I would like to add 13 to both sides of my equation. And anytime I add the same thing to both sides of my equation, I'm using the addition property. And let's see, I want to combine all my like terms, which means I'm going to simplify. So here my 13's go away. That leaves me with 2x. And negative 27 plus 13 is negative 14. And again, that's the simplifying property. I want to divide both sides by 2 in order to get rid of the 2 over here on this side. So actually, let me go ahead and write that out. Go ahead and write out 2x over 2 equals negative 14 over 2. And anytime I divide both sides of my equation by the same thing, I'm using the division property. And finally, my last statement, I simplify this by canceling my 2's, which gives me x. Negative 14 divided by 2 is negative 7. And I've used the simplifying property again. And I've just proved that x is equal to negative 7.